In my class, we were challenged to build robots that were capable of tracking a line on a track, as well as picking up different colored soda cans placed along said track. So what I did is I designed a robot that would have a claw at the front end, a line tracking sensor array, and then behind that it would use a conveyor belt and a series of gates to move the cans from the conveyor belt into the different hoppers. After building the base platform and mating it with the line sensing array, a powered wheel, and steering mechanism, I attempted to build the conveyor belt design. However, after testing in a mock-up, I found that this design was rather impractical to build and would take much longer to operate than I was expecting. So I decided to step away from that, and my next move was to build the can grabbing claw. I chose to build the grabber that used two gears with arms attached to the gears, and the gears would mesh with each other, and one of them would be rotated by a servo motor. I chose a servo motor because I could get an accurate level of motion. It'd be easy to code for. So I created the claw, and I got it working, and it was totally separate from the robot itself. And then I measured out where a can would be in front of the robot and how high up from the ground my claw should be, and I built an armature to hold the claw in place at the right height from the ground to grab the claw. I even did some testing here and made sure that it would grab the can right about midway up before I permanently attached it to the structure. Once I had the claw configured, my next goal was to figure out how to sort the cans into hoppers or some sort of bin. I came up with this kind of hopper cradle, kind of hammock device, and it would sit behind the claw, so the claw would raise up and it would actually dump behind it, so the claw would let go and the cans would fall behind the claw and into this hopper. And again, I chose a servo motor to use this hopper because I didn't have to rotate it too terribly far to get it to dump to one side or the other. It would make my code simple and it'd be very easy for me to control. So once I had these elements in place, I had to figure out where to store the cans. So can storage was probably my biggest design challenge in this stage of the process. Initially, I was going to use these plastic bins with the main body of my robot and the hopper, the can sorting hopper. I would have had to cut away a section of each plastic bin, and my instructor was not a fan of that idea. So I ended up using these metal strips that kind of ended up looking like legs poking off the side of my robot as the can storage. And I bent them to hold roughly 4 cans on either side, and it also kept them from sliding forward and backwards and out the sides of the robot. After I got everything assembled together, my first test was to see if this robot would follow the line on the course. And I did a bunch of testing and eventually got it to run the course successfully, which made me very happy. And it made me think, oh, this is going to work. This project's going to go smoothly. Once I got the line tracking going, my next move was to get it to sort cans. Now, I wasn't sorting cans and running the line. It was just getting the cans running, can sorting operational, and then I would choose to move to integrate line tracking and can sorting together. I chose to mount the color sensor for the cans on my claw. My theory was that I could get the color sensor as close to the can as possible to get an accurate reading. In order to get the robot to see the cans and where they were, I used an ultrasonic sensor to see the can. So what the sensor would do is it would ping out a sound wave, and then the object or the can in front of it would return that sound wave and the sensor would measure the distance to the can, and I chose a distance of 9 centimeters. That worked out well for me. So I had that, and I got it working. Everything kind of worked smoothly. I was able to sort the cans perfect. God! One of the most challenging parts of this whole project was getting the robot to track the line and to sort the cans. I spent several hours trying to make both of these things work together harmoniously. However, that was not the case. It was very difficult to get this whole thing to work, and what I found out I needed to do was just eliminate one variable at a time. What would happen in the can sorting is the claw would lift up the can and drop it into the chute, to the chute that passes into the hopper, and the cans would get stuck on the chute. So what I had devised was, while the claw was in the raised position, that I would use it and open and close it rapidly to create an agitator which would agitate the can down the chute. This worked successfully almost every time. There were a few instances where the can still remained stuck, or it would free itself after the robot had begun to roll forwards, but the rest of the time, the agitator would work. I used a for loop in order to get this to open and close initially 25 times, and then I brought it up to 35 times. And then, to be absolutely sure that I had eliminated that variable, I brought it up again to 40 times. So each time on my successful runs, the robot would open and close its claws 40 times in order to prevent the cans from getting stuck in the chute. Another issue I encountered was that as the cans left the hopper and into their respective storage bins, that they'd often bounce, and sometimes they'd bounce out of the storage containers. So what I did is I put some metal posts vertically up on the metal legs to help create kind of a fence. And even then, that was successful, but it still had a couple times that cans would jump out or they'd land funny. And what I did was I made an edge, a kind of fence, another fence out of rubber bands. And these rubber bands would help keep the cans from jumping out, passing through the gaps. So that was another eliminated variable that I had. The main thing, one of the bigger variables that I had to eliminate, was the steering. My steering mechanism was not the strongest part on this robot. It was probably one of the weaker links in my chain. And I found out that the post that I was holding it onto, the screw would come loose, and as the turning motor would engage the gear that I had onto the steering mechanism, that after 3 or 4 runs, the screw would come loose, and then that would cause the gears to disengage each other, and I would lose steering, which was not my favorite thing to do.